Hello. Hello, Chetan. Yeah, we will start very soon. We'll just wait for 5 minutes so that other can also join. Okay, we should start now. Okay, how many of you are attending this for the first time? No, Ashish, I am on the first slide only. Chetan, Arun, Ashwin, are you attending this session for the first time? Okay. So basically, this session is for intermediate to advanced. The first part we already completed last week. Since I'm seeing many of you are attending this for the first time, so I should go from the first part. So I you will be on the let's begin. So what is Elasticsearch? Elasticsearch is a NoSQL database, and it stores the data in the form of JSON documents. If you're coming from RDBMS database system, then you know that on RDBMS we create tables, rows, columns, but on NoSQL databases like Elasticsearch, we have documents. So let's go through the definition. Elasticsearch is a document-oriented database designed to store, retrieve, and manage document-oriented or semi-structured data. When you use Elasticsearch, you store data in JSON document form. Then you query them for retrieval. So let's go through the Elasticsearch story, how it's started and who created Elasticsearch. So the founder of Elasticsearch is Shai Benon. Many years ago, a newly married unemployed developer called Shai Benon followed his wife to London, where she was studying to be a chef. While looking for gainful employment, he started playing with an early version of Lucene with the intent of building his wife a recipe search engine. Working directly with Lucene can be tricky, so Shai started work on an abstraction layer to make it easier for Java programmers to add search to their application. So he released this as his first open source project called Compass. So the first name of Elasticsearch, when he released it as an open source project, he named it as Campus. Then Shai took a job at Gigaspace. The need for high performance real time distributed search engine was obvious, and he decided to rewrite the Compass library as a standalone server called Elasticsearch. The first public release came out in February 2010. A company has formed around Elasticsearch to provide commercial support and to develop new features. But Elasticsearch is and forever will be open source and available to all. He is a great example of how a single person perseverance for a long time can create a world-class product. So now you know the story, how he started, how the Shai started building a Elasticsearch. The first version of Elasticsearch, which he open sourced in the name of Compass. Then, on 2010, he renamed and modified it as a standalone server called Elasticsearch. So, this is Shai Benon, the CEO of Elasticsearch. On right side, you can see his family and his wife, for whom she started working on recipe search engine. While creating recipe search engine, he developed Elasticsearch. L- Let's see overview of Elasticsearch. It's an open source search server written in Java over Apache Lucene library. So the core functionality of Elasticsearch is based on Apache Lucene library used to index any kind of heterogeneous data, enables real-time ability to search through index, has a REST API web interface with JSON output. So let's see what is the base of Elasticsearch. It's Apache Lucene. It's a free open source search engine library written in Java. It's useful in optimizing speed and performance in finding relevant documents on every search query. An index of 10,000 documents can be queried within milliseconds. So you can see this open source search engine library is very fast. Thousands and thousands of documents we can query, we can search and found it within milliseconds. So why everyone wants to use Elasticsearch? Is it scalable? Yes, Elasticsearch is very scalable. We can horizontally scale our Elasticsearch cluster. We can add new nodes to increase our Elasticsearch cluster capability. If we want to add more data into our Elasticsearch, we can add more shards into our Elasticsearch. We will come to know what are the shards nodes cluster in our Elasticsearch. And if you want to increase our availability of Elasticsearch, then we can increase our replica per shard. What are the advanced features of Elasticsearch? It supports nested documents like child parent, like MySQL join, percolation index, store queries in Elastic, send it documents, get returned which queries match, index warming. There we can register search queries that cause heavy load, new data added to index will be warmed. So next time query is executed, pre-cached. So for making Elasticsearch fast, it stores the index into memory. So let's see the basic concept of Elasticsearch. So here you will get to know what is cluster, near real-time search, index, node, shard, mapping, types, and many more. Let's see what are the terminology which we have on Elasticsearch. If you are coming from RDBMS, databases, index, SQL, select queries, and update queries. So on Elasticsearch, if you need to create a database, you will create an index. For tables on Elasticsearch, you will create a type. For a row, you will create a document. And the columns here are called field. Before creating any table on MySQL or any RDMS database system, you are defining the schema of the table. Here we have mapping for the Elasticsearch. Then we have index. On Elasticsearch, everything is indexed. And on Elasticsearch, we called it as inverted index. We have SQL, and on Elasticsearch, we have query DSL. DSL stands for Domain Specific Language. For doing any query on Elasticsearch, we are using RESTful APIs like get, post, put, delete, head for interacting with our Elasticsearch server. So let's see indexing. As you know, on Elasticsearch, we have the database as index. Elasticsearch is able to achieve fast search responses because instead of searching the text directly, it searches an index instead. This is like retrieving pages in a book related to a keyword by scanning the index at the back of a book, as opposed to searching every word of every page of the book. This type of index is called inverted index because it inverts a page centric data structure, that is, pages into words, to a keyword centric data structure, words into pages. Elasticsearch uses Apache Lucene to create and manage this inverted index. So indexing is the core feature of Elasticsearch. As you know, Elasticsearch is built on Apache Lucene, which is a standalone search engine written in Java. So here we have to see that Lucene stores the data not in the form of rows, it stores the data in the form of terms or tokens. Suppose we have a string like my name is Manav. So on Lucene, it will store as single tokens. Like my name is Manav will be divided into multiple tokens. My will be one token, name is one token, Manav is one token. And by seeing the term, it maps the document or it maps the column. I will clarify it more in the next slides. Let's see. Elasticsearch is distributed and highly available. multiple servers, that is nodes running in a cluster. When we start our Elasticsearch service, either on AWS Cloud or any Elasticsearch hosting platform, we create a cluster. A cluster is a combination of multiple server or nodes, and one cluster act as a single service. Nodes in a cluster that store data and nodes that just help in speeding up search queries. So let's see sharding. Indices are sharded. Each shard can have 0 or more replicas. Replicas on different server. On sharding, we have two kind of shardings. One is the primary sharding, which we stored on primary shard, and there is replica, where we keep the copy of our primary shard. So what is shard basically? Shard is a Apache Lucene instance. We already know what is Apache Lucene. It stores the data in inverted form, inverted index form. And on Elasticsearch, we called it as a shard. So whatever we insert into Elasticsearch, it goes into Apache Lucene, which is also known as shard. First, the data goes into primary shard, then a copy of primary shard is replicated into replicas or replica shards. While creating an index, we can define the number of primary shards and the number of replica shards. So that's why sharding is fully configurable. Sorry. So we can configure sharding while creating an index. The primary shard is also known as master shard, which is responsible for distribution and balancing of shards. Let's move on. On this diagram, you can see we have multiple shards at the bottom. An index is a combination of multiple shards. As I told you, while creating an index means a database on Elasticsearch. So while creating an index, we can define the number of shards we want for our index. On shards, we have two types of shards: master or primary shard, replica shards. So whenever someone query, here we have a sample query which search for a person which person name is Jack. It's a match query. It goes to Elasticsearch API. From Elasticsearch API, it goes to a shard. So the first shard which gets this query is called coordinator shard. Then the coordinator shards will request to relevant shards. When it finds the data, the matching data, it will give response back into the API, and on response you can see how much time it took. It's 13, and then how many shards were there and how many documents it found. On total you can see it's written 5. That means 5 documents are available with the name Jack. So let's see what is cluster. A cluster is a collection of one or more servers that together holds entire data and give federated indexing and search capabilities across all servers. As I told you, when we host our Elasticsearch on any cloud platform, we create a cluster. Cluster is a combination of multiple nodes. NRT, near real time. Elasticsearch is a near real time search platform. That means whenever we put a new document into our index, it becomes searchable. Let's see what is the index. A database is called index on Elasticsearch. The index is a collection of documents that have similar characteristics. For example, we have an index of customer data and another one for a product information. An index is identified by a unique name that refers to the index when performing indexing search, update, and delete operations. In a single cluster, we can define as many indexes as we want. What is a node? A node is a single server that holds some data and participates on the cluster's indexing and querying. A node can be configured to join a specific cluster by the particular cluster name. A single cluster can have as many nodes as we want. A node is simply one Elasticsearch instance. What is a shard? A shard is a subset of documents of an index. An index can be divided into many shards. You already know a shard is an Apache Lucene which stores the exact data of Elasticsearch. Whatever we query, we get it from the shard. Mapping type. If you are coming from RDBMS, you know we create schema for the table. Same as on Elasticsearch, we create mapping. Elasticsearch uses document definition that act as a table. If you put index a document in Elasticsearch, you will notice that it automatically tries to determine the property types. So as we have completed the basics, the terminology of Elasticsearch, now we can move to installation of Elasticsearch. Is it clear till now? Should we should we move further? You can write your comments on the comment box or the live chat box. Okay, thank you, Chetan. So for installing or downloading Elasticsearch, we need to go to elastic.co. When you go to the Elasticsearch website, on the download section, you can see this screen where you can download your free version of Elasticsearch based on your operating system. If you want to install Elasticsearch on Windows, then you have a option of Windows. If you want to install Elasticsearch on Mac operating system, then you have option of Mac OS. So based on your operating system, you can download and run your Elasticsearch instance. So after downloading the Elasticsearch package from Elasticsearch website, you will get a zip file. When you extract that zip file, you can see this project structure. When I unzipped Elasticsearch folder, I got this many folders. So how we can install Elasticsearch? First step we have completed. We have downloaded and unzipped our Elasticsearch downloaded file. For running our Elasticsearch, we need to go to our terminal, or if you are in Windows, then on your PowerShell. Go to your Elasticsearch folder where you have downloaded and unzipped it. That means we have a shell script or bat file for running our Elasticsearch, which is present inside bin folder. Here you can see the first folder is the bin folder. Inside that we have elasticsearch.sh or elasticsearch.bat file. So when you run your Elasticsearch using this command on your terminal or PowerShell, your Elasticsearch will start. To test your Elasticsearch, you need to go to your browser and type localhost 9200, and you can see the response like this. It will give you the name of the system where you installed, the cluster name, the cluster unique UID, the version of Elasticsearch which you are using, the version of Lucene which you have. When you see this page, that means your Elasticsearch is working fine. So the another project or another software which we have for interacting with our Elasticsearch is Cabana. Cabana is also a product from Elasticsearch company, or it's also a open source project. This also you can download from elastic.co/downloads/Cabana. Based on your operating system, you can download your zip file. For installation, when you unzip your Cabana folder, you will see on your config folder you have cabana.yml file. You need to open that cabana.yml file and search for elasticsearch.host. As you know, your Elasticsearch is running on port number 9200. So that address, localhost 9200, that you need to define on Cabana's YML file. Save it, and for running Cabana, again you need to go to your terminal, go to the bin folder of downloaded Cabana, then write command bin/Cabana. Your Cabana will start running. Here you need to understand you have to create two terminals. On one terminal, your Elasticsearch will run on port number 9200, and on another terminal, your Cabana will run on port number 5601. To test your Cabana, you need to open browser and type the address localhost 5601. You can see this welcome screen of Cabana. So let's begin by creating an index using our Cabana dashboard. So while creating an index, we need to define three things. One is the setting for the index, second, mapping for the fields in the index, third is the alias. As you know, Elasticsearch work on RESTful APIs. So for doing any kind of CRUD operation on Elasticsearch, we need to call RESTful API. Your Elasticsearch is running on localhost 9200. If you see this query is for creating a new index and putting a new book in your books index. Suppose I have already created a index with the name as books and I want to add a new book with ID 1 into my books index. Then I can use this query. Before creating a new index, we have to define three things. One is the setting for the index, mapping for the data field on index, and the alias of the index. For defining the setting of index, we need to write this query on our Cabana platform. So it's a put API call and the endpoint we have is my index. It takes the parameter settings. Inside settings, we have number of shards and number of replicas. As on the previous slides, I already informed you that while creating a index, we can define the number of shards we want. The number of shards here is 3, means the number of primary shard or the master shard is 3. Number of replicas means the number of replica shards, which is 2. So after creating setting for our new index, the index name is my index. We need to define mapping for the data fields inside our index. Mapping is just like defining a schema for our table, like how many columns will be there, what will be the column name and the data type that we define on mapping. Mapping is the process of defining how a document and the fields it contains are stored and indexed. For instance, use mapping to define which string field should be treated as full text field, which fields contain numbers, data, and geolocation, the format of data values. Custom rule to control the mapping for dynamically added fields. As you can see, I am using Mac operating system and I have already downloaded Elasticsearch and Cabana into my system. On my terminal, I have started two services. In, in one, I am running Elasticsearch, that I can check that localhost 9200. It gives me this data. That means my Elasticsearch cluster is running fine. On another tab, I am running Cabana, that I can access using localhost 5601. So Cabana Dashboard is the user interface for Elasticsearch. It's a separate project which we need to download from the Elasticsearch website. When you open this dashboard, on the left side, you can see Dev Tools. When you click on the Dev Tools, you can define your queries here for interacting with the Elasticsearch. On the last slide, we have seen how we can create our new index. While creating our new index, we need to define three things. One is the setting, second mapping, third is the alias. So starting from the first step, I am creating a new index with the name my_index. In that, I am defining setting, how many number of primary shards I want, and how many numbers of replica shards I want. These details I can define on setting parts. You can see it's a put API call which I am doing on Elasticsearch. When I click the play button here, you can see on response that this information, a new index has been created successfully, shard has been acknowledged, and index name with my index is created successfully. For checking my index, I can type a new query, a get HTTP call with my index name. As my index name is my index, when I play this query goes into our Elasticsearch, which is running on port number 9200, and it gives the data back into Cabana. So now for my index, I have defined the setting, so you can see it here. On setting, I have defined number of shards equal to 3, number of replicas equal to 2, but still you can see the alias and mapping fields are blank. So we need to define the mapping or the schema for our newly created my index. You can give your own index names. For example, I have given index name as my_index. Setting already we have defined. Now for defining the mapping, we have again a put call in which we pass the properties that for my index I want a field called age and it will be of integer type, email will be a keyword type, name of text type. Same as RDBMS, we define integer, text, varchar. Okay, when I click on the play button, I get a response as acknowledged true, means the query ran successfully. Again, I will go and check on my index. Now I can see the mapping of our index. Age has been defined, email, and the name. So two things we have defined. Now we have alias as blank. So for defining alias, alias is like a nickname or another name for your index. So I want to add a new alias for my index. My index name is my underscore index and I want to give a alias for that as my index without underscore. I can give any alias name and as many aliases I want. So when I click, it's a post call which I am doing on this endpoint. I got acknowledged as true, means the query ran successfully. Again, I can go and check get my index. I play this and I can see on alias my index is defined. The benefit of using alias is that by this name also I can query my index. If I will show you, so you can see we have alias name also here. When I click on the play button, I will get the same response because my index is pointing to my underscore index. Okay, if you want to insert some field into our newly created index, then we can do a post call for that. On Elasticsearch, we have multiple APIs for getting information from the Elasticsearch. If we want to know how many indexes, how many databases do we have on Elasticsearch, then we have a query get/indices. Here you can see how many indexes do we have. As I have created a new index with the name of my index, my underscore index, you can see it here. When we create an index on Elasticsearch, it gives a unique index is 0 because as of now we had only created our index. We have not inserted any data into our index. You can define your index without the setting, mapping, and alias also. For that, you need to call put API with the index name. But creating a new index without setting mapping is not recommended. So for inserting a new document with the help of this query, I have created a new index called books. For checking it, I can call cat indices. Here you can see books is available in the list of indexes. It also don't have any document right now. I insert a new book into my books index using the post call, and you can see a document has been created. If I go on index, we can see the document which I inserted, the title is testing 1, is available when I queried that particular index. So for this query matches all the documents which we have and returns the response in this format. As for books, we had not defined the number of shards. By default, it has taken the number of shards as 1. We have inserted one document on books so that we can see on hits array. The index name is books, type is book, ID of that particular document, and inside the source we can see the data which we passed for creating a document. Here I have passed title as testing 1, author as tester, and pages as 1. So till now you have seen how we can create a new index with setting, mapping, and alias, and how we can create an index without setting, mapping, and alias. For deleting any index, we can call delete http method, and we have to pass the book's name. Okay, if you want to implement your Elasticsearch queries from your web application, then you need the RESTful APIs. So Kibana gives us facility to copy the curl. Suppose I am taking delete books, and on clicking this gear icon, I can copy as curl. If I open my Postman, on Postman is a software which we used for testing our REST APIs. So on Postman, if I go and paste the curl query, which I got from the Kibana, I can import it, and it will create a new REST API call for me inside Postman. And if you are a web developer, you can use these APIs to integrate in your web application. And when I call this API with get with delete HTTP method, I get the response as acknowledged true. Means this particular index books has been deleted from Elasticsearch. Here you can see that I am calling port number 9200. That is the same port number on which our Elasticsearch server is running. So let's move and see how we can do advanced queries on Elasticsearch and a deep dive into Elasticsearch, Lucene, and sharding. So now on this part, we are going from intermediate to advanced of Elasticsearch. In this, we will see what is analysis and analyzer on Elasticsearch. So what is analysis? Analysis is the process of converting text into tokens or terms, which are added to inverted index for searching. At the starting of our session, I informed you that we are storing all our data into Apache Lucene, which is a standalone search engine, and it stores the data in the form of inverted index. Means it stores the information which we passed on it into tokens, and that token it map with the corresponding document. So analysis is the process of converting text into tokens. Analysis is performed by an analyzer, which can be either a built-in analyzer or a custom analyzer defined per index. So what is an analyzer? Analyzer can be of two types. One will be built-in analyzer, which Elasticsearch give us by default, and custom analyzer, which we can create of our own. So analyzer is a package which contains three lower level building blocks. For defining an analyzer, we need three things: character filters, tokenizer, token filter. In that, character filter and token filters are optional. At index time, if no analyzer has been specified, it looks for an analyzer in the index setting called default. Failing that, it defaults to using the standard analyzer. This means when we create a new index on our Elasticsearch, and while creating index, we define the setting. Inside setting, we can define our analyzers. Like we have defined the number of shards and replica inside the setting object. If we are not defining analyzer inside the settings, by default it will take the standard analyzer, which is a built-in analyzer on Elasticsearch. So the first type of analyzer is character filter. Character filters are used to pre-process the stream of characters before it is passed to tokenizer. So when we want to insert a new document, a new data into our index, it is first processed. It is first divided into tokens or terms. Then it goes and stores into shard or Lucene. We are not directly putting the data into Lucene or our shard. We are first processing it. Elasticsearch have by default analyzers which process the data, which divides the data into terms and put it into Lucene for indexing. So this is the core thing why the Elasticsearch is fast, because it uses inverted index, and for creating the inverted index we have analyzers. When we pass any data, it first analyzed or processed by the analyzer, then it goes into shard. So the first building block of analyzer is character filter. It takes the stream of characters and divide it into or process it. After processing, it pass the data into tokenizer, the second step of analyzer. So first the data comes into character filters, then it goes to tokenizer, then the token filter. Elasticsearch has a number of built-in character filters which can be used to build custom analyzer. We can build our own custom analyzer using the built-in character filter. So built in character filters, we have HTML strip character filter. When we pass a string containing HTML tags, so the work of this character filter is to remove that text before inserting into Elasticsearch shard. Because when we want to insert some data, we don't want to put the HTML tags along with it, because no one is going to search based on HTML tag. So the manipulation part can be done using analyzer. We can pre-process our data and we can store it into Elasticsearch using our analyzers. Then we have mapping character filter, which is used for replacing some words. We have pattern replace character, which is also for replacing, but it uses regular expression for it. So let's see how the HTML strip character filter work. So this thing we can test on our Cabana. In Cabana, we have to pass this query. We have to do a post HTTP call with the endpoint as underscore analyze. On the data part, we have to pass this parameters. Tokenizer, we are using keyword tokenizer. On char filter, we are using HTML strip and the text which we want to parse. When we pass this, I am so happy text which is written on HTML format, when we pass it or run it through HTML strip, it will give a response which you can see at the bottom. I am so happy. The HTML text like P, paragraph, B bold has been removed from our HTML text. So that is the work of HTML strip, to remove the HTML text from our given text string. Now on the second part, after character filter, the second thing is tokenizer. On tokenizer, again we have built-in tokenizer and custom tokenizers. Tokenizer receive a stream of character, break it into individual tokens. We have three built-in tokenizer: word-oriented tokenizer, partial word tokenizer, structured text tokenizer. So let's see what is word-oriented tokenizer. On word-oriented tokenizer, we have multiple inbuilt tokenizers like standard tokenizer, letter tokenizer, lowercase, uppercase, white space, URL, EML, email tokenizer, classic tokenizer, Thai tokenizer. The primary work of tokenizer is to divide the stream of words into individual words or individual tokens. We have, suppose, lower case tokenizer. The work of lower case tokenizer will be to change all the characters which it receives and convert it into lowercase words. White space tokenizer, it will divide the string based on white space. URL, EML, email tokenizer, it will extract the email or URLs from the string as a single token, as a single word. Classic tokenizer is a grammar based tokenizer for the English language. Here you can see an example of standard tokenizer and how we can use it. For this, we will use post underscore analyze. The name of the tokenizer is a standard tokenizer. The text which we want to tokenize. You can see on the example, when I passed that text query, it on response, it gave an array containing multiple words. Partial word tokenizer, it's another tokenizer which is used for partial word matching. On any search engine, you have seen that whenever you pass some words, whenever you write some words, it's give you autocomplete kind of feature. When you write QU, it will give you autocomplete feature as cook or other words which you can use. So this feature is also available on Elasticsearch, and for this we use Engram Tokenizer. So what it does, it divides a particular word into its n-grams. N-gram is like a sliding window of continuous letter. Suppose I have a word as quick and I want to tokenize it into Ngram, then on Ngram I have to define two things on isprop as a setting. On Ngrams I have to define the minimum number and the maximum number of Ngrams. Suppose I have a word quick, Quick. If I want to pass it into Ngram tokenizer, the quick word will be divided into Ui, Ic, and Ck. As on configuration, I have defined minimum length and maximum length as 2. That's why the word is divided into Ngrams of length 2. Same as Ngram, we have edge Ngram tokenizer. But the difference here is that on Ngram, second letter, third letter is also covered. But when we use edge Ngram, always the first letter will be present. The first starting letters will be present. You can compare the output of both Ngram example and edge Ngram. You will see when we divide our word quick using edge Ngram tokenizer, it's divided into Quic, quick. So that is partial word tokenizer. Now we have structured text tokenizer. On structured text tokenizer, we have multiple inbuilt tokenizers like keyword tokenizer, pattern tokenizer, simple pattern tokenizer, char group tokenizer, simple pattern split tokenizer, path tokenizer. For the path tokenizer, suppose we want to store the file system path, then this can be stored using the path tokenizer. Suppose on example we have foo/bar/base. So when we tokenize this using the path tokenizer, we'll get the output as foo bar, and foo bar base. So it creates tree component for each path of our file system. So let's see in demo how we can use tokenizers and analytics analysis and analyzer on our Elasticsearch. Again, I'm going to my Cabana dashboard that is present on localhost 5601, which is running on my terminal locally. Here on Cabana dashboard, I need to go to the dev tools. On dev tools, I can write my own queries and I can run it on my locally running Elasticsearch service. So on this example, we'll see how we can use built-in analyzers and custom analyzer. I'm using Analyze API for that. It's a get call on endpoint of underscore analyze. Extra query parameters I can pass as format it as a text, make it a pretty looking response, and on tokenizer I want to use standard tokenizer, and on text I am passing a text. Or okay, when we tokenize this using the standard tokenizer, this string is converted into multiple tokens. One token is my name is and John. Start offsets define that from which character it starts, the index value of that in string. So it is starting from 0 and the length is 2. So end offset is 2. It's a alpha num kind of a type. Position is 0. Then we have a name. Name is starting from 3 because my starts from 0, 0, 1, 2, and from the third place name is started. It has 4 characters, that's why the end offset is 7. Position is 1. Then we have is starting from, so here you can see the basic example of a standard analyzer. An analyzer contains 3 things: char filter, tokenizer, and token filter. In this example, we are testing the tokenizer of analyzer. On tokenizer also we have standard tokenizer and multiple tokenizers. We can create our own tokenizer also. So let's see how we can create our tokenizer own tokenizer. So this query, while creating a new index with the name of my name, inside setting, previously we have seen inside setting I have passed the number of shards and replicas. Here inside setting I am passing the analyzer, and I am creating my own analyzer with the name my custom analyzer, type custom. On tokenizer I am using standard tokenizer. On char filter I am using HTML strip, and on token filter I am using lowercase and ASCII full D. When I click the play button, it gives, that's why I can't create it again. So for creating it again, I need to delete this already created index. So for deleting already created index, we need to call delete HTTP method along with the index name. When I click this one, I get the response acknowledged true. That means the index has been deleted successfully. Again, I create the index by passing my custom analyzer, which I have defined here. For defining a custom analyzer, we need to give 3 things. One is the tokenizer, character filter, and token filter. Tokenizer is compulsory, char filter and token filters are optional. When again I run this one, as I have deleted the old index, Now it can create a new index, and on response we can see acknowledged as true. And index has been created successfully with the name my underscore index. So for testing this analyzer, I can do a post call on my index with the endpoint of underscore analyze. I can give my analyzer name. I have created a custom analyzer. That's why I have given the name of my custom analyzer on analyzer field. Text. This text I need to parse through my custom analyzer. So let's see what our custom analyzer is doing. First, the data comes into character filter, and on character filter I am using by default character filter, built-in character filter from the given input. So this is the input I am going to pass inside text field. So character filter will remove the B and the B tag from the string. Then after removing that, it will pass into standard tokenizer. Standard tokenizer will divide each word into separate terms, separate tokens. Is will be divided separately, this will be divided separately, who will be divided separately. Then it comes to token filter. Token filter will lowercase the word is will be converted into lowercase, and we have ASCII folding. Let's run this query. So after running this query, you can see the word is divided into 4 parts. Is converted into small is, lowercase is, and HTML tags which we have has been removed. So this is how we can create our own cluster and we can test it out. So whenever we pass a new document into my index, and if it contains HTML tags, that HTML tags will be removed before inserting it into our Elasticsearch. And we can query based on these tokens. Let's see how a HTML strip tokenizer works separately. For that we have a post, and we need to give char filter as HTML strip. We need to pass HTML string, and when I run this one, HTML tags will be removed and I get in token as I am so happy. If I will show you how the standard tokenizer work, on standard tokenizer I am passing this string, and when I play this one, you can see the string is divided into multiple single words or tokens. So now you understand how we can create our own analyzer, or how we can use the custom built-in analyzers on Elasticsearch. Let's see some of the cluster APIs which we can use on our Elasticsearch. So for finding a particular index, you know, Elasticsearch stores the data inside Apache Lucene search engine in the form of segments. Whenever we pass a new data into Elasticsearch, the data is processed using analyzer, divided into tokens, and these tokens are stored into Apache Lucene in the form of inverted index. Now inside Apache Lucene, every data is stored in the form of segments. To find how many segments do we have for our particular index, we have this query in which we can see how many segments do we have of Lucene for our particular index. For this, we can do a get call on myIndex. MyIndex is the name of our custom created index. Underscore segment will give you the detail of segments. Segments are stored inside Lucene. So here you can see on shard 0, we have a routing and state started. It's a primary shard, that's why it's a true. Node, every node have a unique number. Committed segments, how many segments do we have? That we can see using underscore segments API. To see cluster segments, we have underscore cat slash segments API. In that we can see the cluster segments. To check the number of clusters or master cluster, we can call cat masters. When we run this, we see we are running only one cluster in our system. It's running on a local host, that's why it's written 127.0.0.1, which means local host, and the node name is the system name dot local. This ID of the cluster is auto generated. So now we came to the end of our session. If you have any kind of a doubt, you can ask me on live chat. 5 minutes I can clarify your doubts, then we can close this session. Okay, Chetan Sachdev is asking, are you going to cover log stash as well? I think log stash now we can't cover it. Maybe on the next session we can cover log stash and ELK. ELK. Is that fine, Chetan? If you have any kind of a doubt, you can write on the chat box. All right, thank you for joining this live session of Elasticsearch. Chetan is asking some question. Chetan Sachdev, can Elasticsearch be used as a replacement of MongoDB? Okay, it's an interesting question. So it totally depends on your working scenario. Some people use Elasticsearch as a secondary database, and some people use it for their primary database. Are there any performance issues when using Elasticsearch compared to MongoDB? Yeah, every databases have their own pros and cons. Elasticsearch is basically built for doing search operation, and MongoDB is also a NoSQL DB, but the main agenda of creating MongoDB is to create is to support the big data, is to support the NoSQL. If your application is more search oriented, then you should go for Elasticsearch. And if you want to just store the data, you are not focusing on search part more, then you can go for MongoDB, because every database have its own specification, and based on specification, based on use case, we choose our database. Performance wise, both are scalable. So is that answer satisfy you? All right, Chetan. Okay, thank you everyone for joining this session. We'll meet on the next live session. Thank you for joining. Have a nice day.